Chapter 11, Keeping Time with the Skies, Notes and Summary from Grade 8, Subject Science, Book Curiosity. Introduction. Humans have always observed the sky to measure time. Day and night, phases of the moon, and changing seasons are natural periodic events that helped in the creation of clocks and calendars. The moon's changing shape, phases, and the sun's apparent motion are key to understanding timekeeping. 11.1 How does the moon's appearance change and why? The moon does not emit its own light, it shines by reflecting sunlight. The shape of the bright portion of the moon changes daily. These are called phases of the moon. The moon takes about 29.5 days to complete one cycle of phases. The moon rises about 50 minutes later each day. 11.1.1 Phases of the moon: full moon, Purnima, entire illuminated portion visible; new moon, Amavasya, no illuminated portion visible; waxing, Shukla Paksha, bright portion increases from new moon to full moon; waning, Krishna Paksha, bright portion decreases from full moon to new moon; crescent moon, less than half illuminated; gibbous moon, more than half illuminated; cycle, full moon, waning, new moon, waxing, full moon, approximately 1 month. 11.1.2 Locating the moon. On full moon day, the moon is opposite the sun. Sun rises in east, moon sets in west. Each day, the moon appears closer to the sun in the sky. Waxing moon, best seen at sunset; waning moon, best seen at sunrise. The moon does not rise exactly at sunset. Instead, it rises approximately 50 minutes later each day. 11.1.3 Making sense of our observations. Half of the moon is always illuminated by the sun. From Earth, we see different portions of this illuminated half causes phases. Phases are not due to Earth's shadow that causes eclipses. New moon, moon closest to sun; full moon, moon farthest from sun. The moon's orbit plus Earth's rotation explains why the moon appears shifted each day. 11.2 How did calendars come into existence? Day, Earth's rotation on its axis 24 hours. Month, moon's phases cycle approximately 29.5 days. Year, Earth's revolution around the sun approximately 365 and 1/4 days. These cycles formed the basis of calendars. 11.2.1 Lunar Calendars. Based on moon's phases, one lunar month is equals to 29.5 days, 12 months is equals to 354 days. Lunar year is shorter than solar year. Seasons shift. Example: Islamic calendar. 11.2.2 Solar calendars. Based on Earth's revolution around the sun. One solar year is equals to 365 days with leap year adjustment. Gregorian calendar is a solar calendar. Leap year rule: add 1 day every 4 years. February 29. Correction: skip leap year every 100 years but keep it every 400 years. 11.2.3 Luni-solar calendars. Combine moon's phases plus solar year. 12 lunar months is equals to 354 days. Short day by approximately 11 days. Every 2 to 3 years an extra month, Adhik Mas, is added. Used in many Indian traditional calendars. Two systems: a month ends on new moon; Purnimant, month ends on full moon. 11.2.4 The Indian national calendar, adopted in 1957 Shaka era. Solar calendar used along with Gregorian calendar. Year begin on 22nd March, 21st March in leap years. Months have 30 or 31 days. Names of months: Chaitra, Vaishakha, Jyeshtha, Ashadha, Shravana, Bhadrapada, Ashwin, Kartika, Margashirsha, Pausha, Magha, Falguna. Be a scientist. Meghnad, Saha, 1893 to 1956. Indian astrophysicist. Developed the Saha equation to study stellar temperatures. Founded the Saha Institute of Nuclear Physics, Kolkata. chairperson of the Calendar Reform Committee that standardized the Indian national calendar. 11.3 are festivals related to astronomical phenomena. Many Indian festivals are linked to moon's phases or seasonal cycles. Examples: Diwali, new moon of Kartika; Holi, full moon of Falguna; Eid-ul-Fitr, crescent moon after Ramzan; Makar Sankranti, Pongal, Bihu, solar events, solstice, equinoxes. Festivals shift in Gregorian calendar because Luni-solar calendars differ from solar year. 11.4 Why do we launch artificial satellites in space? Moon is natural satellite. Humans launch artificial satellites. Orbit Earth at approximately 800 km altitude. Complete one orbit in approximately 100 minutes. Uses: communication, navigation GPS, weather forecasting, disaster management, scientific research. Examples: Cartosat mapping, Astrosat astronomy, Chandrayaan moon, Mangalyaan Mars, Aditya L1 sun. Problem: space debris from old satellites. Next, be a scientist. Vikram, Ambalal, Sarabhai, 1919 to 1971, known as father of the Indian space program, established ISRO and promoted satellite technology for development. Vikram Sarabhai Space Center VSSC named in his honor. Snapshots summary: phases of the moon occur due to changing positions of Earth, Moon and Sun. One cycle of phases is approximately 29.5 days, a month. Calendars are based on natural cycles: day, Earth's rotation; month, Moon's phases; year, Earth's revolution around Sun. Lunar, solar and luni-solar calendars exist. Indian national calendar is a solar calendar, Shaka era. Festivals are linked to astronomical events. Artificial satellites are launched for communication, navigation, weather and research. Meghnad, Saha and Vikram Sarabhai made pioneering contributions to astrophysics and space science. So friends, we have completed notes and summary of chapter 11, Keeping Time with the Skies. You can change the audio language to Hindi, Tamil, Telugu, Malayalam or any other language for better understanding. We will do question answers of this chapter in a separate video. If you like the video, kindly like, hype the video and share it with your friends. Also subscribe to my channel for more such videos. We will meet in the next video. Thank you for watching.